Hello everyone, welcome back to the channel. In this video lecture, we shall solve this problem sum of maximum and minimum. In this problem, we're given an array of size n containing integers, and the task is to find the sum of maximum and minimum elements present in the array. The input format is an array of length n containing integers, while output will be a single integer representing the sum of maximum and minimum element present in the array. The size of the array may go up to 10 raised to the power 5, and the element in the array may go up to 10 raised to the power 5. Let's better understand the problem using an example. Here you can see we have an array of size 5 containing integers, and we want to find the sum of maximum and minimum element present in the array. We can see the minimum element present in the array is 2 and the maximum element present in the array is 18. Hence, the answer would be 2 plus 18, that is 20. Let's try to solve this problem using naive approach. So in the naive approach, all we have to do is to take a pointer and traverse over the array and find the minimum and maximum element. So for that, we initialize two variables, minimum variable and maximum variable. We initialize minimum variable with a very large number and maximum variable with a very small number. Then we iterate over the array and we keep updating the maximum by comparing the current element we are standing with the element which is already present in this variable, maximum variable. And same goes for the minimum variable. We keep updating minimum variable if we find a number in the array which is smaller than the minimum which is already present in this variable. Finally, we return the sum of the maximum and minimum which we extract from here. So this is the very naive approach to solve this problem. The time complexity for this problem is big of n because we are traversing over the array. The space complexity is constant because we are not using any extra space. But there's another way to solve this problem. So in the problem statement, we'll be given as a follow-up that we have to minimize the number of comparisons that we perform in the algorithm. In this algorithm, the number of comparisons in the worst case are n. That is, can we improve upon the number of comparisons that we perform? Let's see how we can do that. The idea is to divide the parent array into two halves and extract minimum and maximum elements of each half of the array. That is, we start with this parent array, we divide it into two halves. This array will return me the maximum and minimum element which is present in this array, that is 2 and 5, because 2 is the minimum element and 5 is the maximum element. Same with this array, this will return me the minimum and maximum element, and we repeat this process recursively for each half. So we keep on dividing the arrays into smaller parts until we get single element separated, and then we return from each sub array the maximum and minimum element to the calling function. Then this array will get these two pairs, so a pair from the left sub array and a pair from the right sub array. Then all we have to do is to find the minimum and maximum element by comparing the elements in these pairs. So how would I extract that? I will compare the first element which I get from this sub array with the first element which I get from this sub array, and I will extract my minimum for this subarray, and the minimum would be 2 because 2 is smaller than 7. Similarly, I will compare the second element of left subarray with the second element of the right subarray, and I will extract my maximum, and the maximum would be 10. So this is how I'm reducing the number of comparisons. All I have to do to make 2 comparisons only, and I extracted my minimum and maximum. Let's see how we can implement this approach in code. So let's see the implementation for the divide and conquer approach. So this is the function sum of max min, which takes in the array and a range L to R. This represents the starting index, this represents the ending index. Initially L is 0, R is n minus 1, and we're calling this function for the given array nums. Then we declare two variables, max and min, where min will store the minimum element of this range and max will store the maximum element of this range. There are three cases. The first and second are the base cases, where either we have reached this position, that is we are left with only single element, or we are left with this type of array where we have two elements. So in case we have only one element, then the same element will be maximum and the same element would be the minimum. Otherwise, if we are left with two elements, then we have to compare these two elements to extract our maximum and minimum. Finally, we have our main case where we have array which has a size greater than 2. In that case, we divide that array at middle point. So this, we are calculating the middle point of the array starting from index L ending at index R. We call the function sum of max min recursively for the left array, that is starting from L going up until mid, and for the right sub array. And since these functions will return me the min and max for the respective ranges, I will get two pairs in these two arrays. Then I have to compare those pairs to extract my maximum and minimum for the range starting from L ending at R. That's what I am doing here. I'm comparing the first element returned by the left subarray with the first element returned by the right subarray to extract my maximum element. I'm assuming that the first element which I am returning is maximum element. Then I'm comparing the second element returned by left subarray with the second element returned by right subarray, and I'm extracting my minimum here. And I'm assuming that the minimum is the second element which is returned in pair. Finally, I return my pair of max and min which I extract from here. So this is how the function is working. I hope you got the idea how we are solving this problem. So basically, if the size is greater than 2, then we have to divide the array into two halves to extract two pairs from the right subarray and from the left subarray. Then we compare those pairs to extract my min and max for the array which we divided initially. That's the idea. And the base cases are when we reach a point where we have only single element or we have two elements. That's all. Let's discuss the time and space complexity for this solution. We can see that initially we have 0 comparisons. Here we have 2 comparisons. Here we have 4 comparisons. Here 8 comparisons. Then if we sum all these values, 0 plus 2 plus 4 plus 8, this will give me a sum of 2 raised to the power k, where k is the height of this tree. So what is the height of this tree depends upon the number of elements which are present in the array. So if there are n elements, then the height would be log n. Why? Because we are dividing n into two halves at each step. Therefore, log n would be the height of this tree. So 2 raised to the power log n gives me n, which is the time complexity for this solution. While the space complexity for this solution is constant because I'm not using any extra space here. Although I am consuming stack space because of my recursive calls, and the stack space consumed is log n. The space complexity is constant because the extra space or the auxiliary space is not used, while the time complexity is linear. Okay, so let's see the code implementation for this solution. So this is the function find min max. It gives me a minimum and maximum element in the form of a vector. A vector is a dynamic array. So I'm implementing the solution in C++. So let's declare, so these are the minimum and maximum variables. They will store the final answer. So this is the first base case where we are left with only single element. So this is the second base case where we are left with two elements in the array. So we find the middle element of the array, then we call the functions recursively for the left subarray and for the right subarray. So these arrays will store the minimum and max for the left and for the right subarrays. Now we want to compare the first element of the pair that we obtain for the left subarray with the first element of the pair that we obtain for right subarray to get the minimum element for the range L to R. So here you can see if the left, so here we are extracting the minimum and maximum for the range L to R, and finally we return the pair minimum, min and max from here. So this function will give me the minimum and maximum element for the range L and R. So that's all how I solve this problem. Let's see the implementation in other languages. This is the implementation in Java, and this is the implementation in Python. So that's all for this video. If you liked it, then make sure to spread the word. I'll see you in the next video.